Hi, Pre-Algebra students, it's Miss Carol, and I'm happy to report that we are on Unit 3 project lesson 15, which means we are on the last lesson for this project. So once you finish this lesson, you can submit the Unit 3 project, and I will get it graded for you. We have 3 questions again. And here's the background. The scientific notation system would not be much good if you couldn't add, subtract, multiply, and divide the numbers. This part of the project will give you some real-world problems to work out using scientific notation. Okay, question 1. By one estimate, there are about 5.7 times 10 to the 4th parks of various sizes in the United States. These parks host a total of 9.4 times 10 to the 9th visitors per year. What is the average number of visitors per park per year? Okay, type your answer in the scientific notation, blah, blah, blah. Okay, so what we need to figure out is if we've got 9.4 times 10 to the 9th visitors and we have 5.7 times 10 to the 4th parks, then what does that average out to visitors per park? And obviously this is not really an accurate number because some parks barely get any people while some parks get, millions of people. So this is just for purposes of math. Okay, so what we're going to do is we're going to take that 9.4 times 10 to the 9th, and we kind of already did a problem similar to this in the last section, so this shouldn't be too unfamiliar. 9.4 times 10 to the 9th, and divide that by 5.7 times 10 to the 4th. Okay. So let's go ahead and take care of those tens right now. We've got the same base, so we can say that this is going to be 9.4 over 5.7 times 10 to the 9 minus 4, or 9.4 over 5.7 times 10 to the 5th power. Okay, so I'm going to get out my calculator. And I'm going to divide 9.4 by 5.7. It's going to be 1 point something. Okay, so I was right. It was 1.6491, and it goes on for a while. So I'm going to round that. I'm going to say it's 1.65. Let's see. Do they say round the decimal to the nearest hundredth? Yes. Okay, so that will work. That often is something students miss, but that direction is right there. So this is 1.65 times 10 to the 5th power. Okay, oops. Let me rewrite that so it's really clear. Okay, so remember that I had to take into account both the integer part of this and then the scientific notation or the exponent part of this. And it really is handy when you're dealing with scientific notation that you can use properties of exponents because your base 10 is the same for both of those. Okay, so I'm going to go ahead and type that in there. 1.65 times 10 to the 5th power. Okay. All right, and I do want to bring up something. Let's say that it had been the other way around. Let's say 5.7 was divided by 9.4, but that our 10 stayed the same as top and bottom. In other words, let's say that this ended up being less than 1. Let's say that we had something in the neighborhood of 0.165 times 10 to the 5th power. Okay, remember that in order for us to be in accurate scientific notation, we always have to have one number to the left of the decimal, and I can always do that by either borrowing or subtracting from my my tens here. So if I had 0.165 and I needed to make it 1.65, I could just borrow a 10. I can multiply by 10 and say 1.65 times 10 to the 4th power. Okay, now that is not the answer for this one. I just wanted to clarify, and I was kind of hoping that they would do this in this lesson, but they didn't. So I wanted to bring that up, that you can borrow from those tens, or you can, if you had something like 10.65 times 10 to the fifth. Well, again, we can only have one number to the left of the decimal, so we would have to go ahead and give a 10 away. We'd say 1.065 times 10 to the sixth power. All right. Again, that's not what happened here, but it is something that you could potentially see on exams, and something that you should be aware of. Okay, let's move on. Question 2. Local parks, as opposed to national or state parks, are funded by county, city, or local governments. The total budget for local parks is 3.5 times 10 to the ninth dollars. The State Park Administration has a total budget of 7.9 times 10 to the 10th. The budget for national parks is 2.86 times 10 to the ninth dollars. What is the total budget for all of these types of parks combined? Okay, so we've got city parks, state parks, and national parks. So essentially what we need to do is add all three of these, all right? So I'm going to put them up here. This is a little bit challenging, but definitely within our scope of ability. So we've got 3.5 times 10 to the ninth, and we are adding that to 7.5 times 10 to the 10th, okay? And then we're adding that to 2.86 times 10 to the ninth. Well, one problem that we have right here is that we're dealing kind of with apples and oranges, 10 to the ninth and 10 to the 10th. We can't just add these numbers. We have to make sure that when we're dealing with these exponents that they need to be kind of in the same category. So let's do this. Let's change this 10th, okay, 10 to the 10th. We're gonna take one of those 10s, and we're gonna say 75 times 10 to the ninth. All right, and then that will allow us to add all three of the left sides. So we've still got a 3.5. We got to make sure we've got our digits lined up correctly. Let me write that in a different place, actually. So let's line up our digits, give ourselves plenty of room. So 3.5 times 10 to the ninth. 75 times 10 to the ninth. And 2.86 times 10 to the ninth. Okay. Now we can add these all up. So I've essentially got a 0.00 here. So I have a 6 here. I have a 5 and an 8 gives me a 13. Okay. I have 4, 9, 11, and 1 and 7 is 8. So I have 81.36 times 10 to the ninth power. But remember, when we are dealing with scientific notation, this is kind of what I was talking about in the last problem. I'm glad they're doing this here. We can only have one number to the left of the decimal, so we are going to have to give one away, all right? And when we give one away, we give it over here, all right? So we're moving that decimal over to the left, and we're going to say 8.136 times 10 to the 10th power, okay? And when we're adding like this, that really makes sense. Your big number is still going to be a big number, even if you're adding some smaller numbers to it. So our 10 to the 10th power is still going to be our magnitude here, where even if we added a couple numbers that were 10 to the ninth, we've still got that 10 to the 10th that's going to dominate our overall number. And that's exactly what happened here. So it is something that makes sense. It says do not round out any digits. All right, so we didn't. Let's go ahead and type that in. 8.136 times 10 to the 10th power. Cool. All right. Go online to find the annual number of visitors there are to national parks in the United States. Choose one park in particular. Find the number of visitors that park has. Okay. So let's first, well, I already searched one. How many visitors? I chose Yellowstone because Yellowstone borders Idaho, and I figured that many of our students have been to Yellowstone. And I found out that 3.8 million people have visited Yellowstone through the end of September. And that's probably from last year, but that's fine. So we're going to say 3.8 million. And million is 10 to the 6th. So 3.8 times 10 to the 6th is Yellowstone. Okay, and then let me do real quick a search for all national parks. All national parks. Is 331 million. Wow. Okay. So get that pencil going. So 331 times 10 to the 6th is all national parks. Okay, what is the ratio between the number of visitors to the park you chose and the number of visitors to all parks? In other words, what is the fraction of visitors that visit just Yellowstone? Okay, so basically that is 3.8 times 10 to the 6th over 331 times 10 to the 6th. Well, if you look at that, those cancel out. So we've got 3.8 over 331. So that's about 1%, just over 1% of the total national parks visitors were going to Yellowstone National Park. Okay, so this is actually what we're looking for, 3.8 over 331, because those 10 to the 6th cancels out. Okay, is this calculation more easily done using scientific notation or standard notation? Well, I personally think the fact that it was written in standard or scientific notation made it really easy to cancel those 10 to the 6th out. If I would have had 3, 8, 0, 0, 0, 0, 0, and 331, 0, 0, 0, 0, 0, 0, yeah, I could certainly have canceled these out, and then realized that I would have 3.8 over 331. Yeah, that I could have done that, but this was really easy. Okay, so what I would type here is all national parks equals 331 times 10 to the 6th, and Yellowstone equals 3.8 times 10 to the 6th. Ratio equals 3.8 times 10 to the 6th over 331 times 10 to the 6th equals 3.8 over 331. Okay. Scientific notation made this very easy because I could quickly cancel out the 10 to the 6th. Okay. Okay, that's all we're looking for here.